Guys, in this video, I will try to cover the differentiation under integration, and I will not show the proof. I just want to tell you the formula. This is the formula. This is called the Lenz's rule for integration under differentiation. Sorry, differentiation under integration. Now, basically, using this formula, you can easily solve any kind of question, and there basically you will face two kind of question. First, using this formula you can easily solve, and the second question is something like you have to use the Feynman trick, and in the next video I will talk about the Feynman trick. So first of all, let's talk about this formula. So you can see this is the formula, and this is the function of x comma z which is given, and the limits are in the form of az and bz. Basically the limits are variable, so we can easily use the partial derivative. So let's move on some questions so that you can understand it more efficiently. So in that question we need to solve this differentiation. So how will we solve? Using the previous formula we can easily solve that. So you can see the bx, I mean the upper limit, I mean the bz is equals to z, and az is equals to 0, right? And f of x comma z is equals to z squared minus x squared into cos x. Very nice. Now first thing which we had to do, wait a moment. Okay, fine. The first thing will be az bz del of f by del of z into dx plus f of v of z comma z into del b del z minus f of a of z comma z into del a by del z. So first we have to differentiate f, I mean partially differentiate f with respect to z. So you can see this will be like this is cos x. Cos x is constant, I mean cos x will be treated as constant because we are differentiating with respect to z, so x will be treated as constant, or any term of x will be treated as constant. So cos x into 2z minus the integration, I mean sorry, the differentiation of x square will be 0 because x square will be treated as constant too. So the differentiation of constant is equals to 0, which is very easy to understand, right? Now this is like dx, and the limits are 0 to z, plus this is like f of z comma z, right, into the differentiation of bz, which is that with respect to del z is nothing but 1, minus this is f of 0 comma z, right, and into this is again 0 because as az is 0, so the differentiation will be also 0. So we have to solve only this part. So you can see this is cos x, and this is like, sorry for a mistake, I had done a mistake, which is this is not fx, this is fz, sorry. So you can see here basically the 2z will be treated as constant, so definitely we can take out it. So the integration of cos x is nothing but sin x with limits 0 to z, plus this is what you can see here, the this is z square minus x square into cos x, and we have to replace x with z. So basically this is like z square minus z square, so this is 0 into 1 minus 0, 0 into something is 0, and this is also 0. So the answer will be like 2z into sine of z minus sine of 0. So the answer is 2z into sine z. Hopefully you can understand the question. So this is the process, and it is very easy to solve. If it will come in an exam, then you can easily solve, you can get easily marks. So remember this formula, you don't need to know the proof. If you want to know the proof, then you can go through another video which I will make definitely in future, but at that moment you don't need to know the proof, you just need to know the formula so that you can easily solve that kind of question, which is very easy to solve. So this is another, I mean, this is an question, this is a question, and let's move on to another question. Well, in that question, the given fx is equals to 0 to 1. So upper limit is 1. This is log of x square plus y square into dy. It's very easy question. Basically, you need to know the formula only. So we have to find out f of, I mean, f dash x. So basically, you have to differentiate fx with respect to x, and there are two variables, so you have to use the partial derivative. So you have to use simply the derivative rule, I mean, Lenz's rule for differentiation under integration. Now, how will we solve? Basically, we have to solve this 0 to 1 log x squared plus y squared into dy. Now you can see the f of x comma y is nothing but log of x squared plus y squared, and b of x is equals to b of x is equals to 1, and a of x is equals to 0, right? So now what we can do, basically we have to solve using that formula, ax to bx. This is f dash x is equals to ax to bx del of f by del of x into dy, plus, actually it is not multiplication symbol, however, so plus f of x comma bx, doesn't matter, you can put it like here also. Basically this is like we have to change the another variable which we are not using. Actually, we have to go through the variable which we have to use for differentiation. Like in that case, the differentiation, I mean, we are using x as the differentiating variable, so we have to take x only, we have to replace the z part, I mean, in that case it is not z, it is y, so that we can get a function which is only consisting x only, right? So this is into del of b by del of x, actually this is bx, minus f of x comma a of x into del of ax by del of x. Now bx and ax are constant, so we don't need to take that part because it will be becoming 0, this will be becoming 0, so 0 plus 0, I mean 0 into 0, sorry, what I'm saying, 0 into something, whatever the value of this portion, doesn't matter, whatever the value of this portion, actually doesn't matter, 0 into something is 0, 0 into something is 0. So we have to solve only this integration, right? Like this is a of x, this is b of x. Now you can see this is the function, and we have to differentiate with respect to x. So this is like 1, I mean, sorry, x square plus y square. Now we have to again differentiate x, so this is like 2x, we have to differentiate y square also, as we are using del x, I mean x as the first variable, so y will be treated as like y will be treated as like constant, so y square, I mean differentiation of y square with respect to x will be 0 into dy. Now it is very easy to solve. This is f dash of x, sorry, well, this is f dash of x. Now 2x will be treated as constant as we are integrating with respect to dy to x. Now we have to integrate 0 to 1, this is dy by x square plus y square. Now in that case, x square will be treated as a constant, right? So this is nothing but the differentiation of tan inverse y by x into 1 by x. Well, hopefully you can understand, right? Now we have to put the limits from 0 to 1. This is 2x by x, we have to put the limit at y, not at the x, right? So this is tan inverse 1 by x minus tan inverse 0. Now this is tan inverse 0, so x will be cancelled out, so the answer is nothing but 2 tan inverse 1 by x. So at the end of the day we will get a function which is, let's say f dash x is treated as gx. So gx is equals to nothing, but maybe it's a constant, maybe it's a kind of function which is x. So be careful. If the function is given as f of y, if the function is given as f of y and we have to differentiate f dash y, then we have to replace this x with b of y basically. And definitely the examiner will give you this thing in the form of y and this thing in the form of y also, but in that case as both of them are constant, so maybe the examiner will not change the value of the limits. So if examiner will give this, then the answer will be changed a little bit. Actually the answer will be changed, like the x will be replaced as y in that case. It depends on the function actually, but in that case it will not change. Actually it will be like same. Actually x will be replaced at y. It depends on the function. So this is all about differentiation under integration. Actually not all about, it is the Lenz's rule only, and this is basically you can say this is the 50% of our syllabus. And in the next video I will talk about the Feynman's trick, where you will see something very powerful integrals, like we will be going to solve this integration from 0 to infinity, which is kind of unsolvable integral. We will solve this kind of integration, tan inverse ax by x square plus a square. I'm not talking about actual function. It will be looking like something similar like that, from 0 to infinity or something like that. However, it depends. So it's very easy. Actually Feynman trick is also easy, but you need to focus at the question so that you don't do any kind of calculation mistake or something like that. In that case there is a very low chance that you will make a kind of calculation mistake in that case, where Lenz's rule is because Lenz's rule is very easy to solve. Just you need to focus, because it's very easy and very like short question. It's like if examiner will give you in your exams, so maybe it will like 3 or 2 marks or something like that. It's very easy to solve. So however, this is all about this video. Thank you for watching, and if you want to subscribe, like, comment, and share, then do it. Just goodbye.